In section 10.7 day 2, we'll take a look at now converting polar and rectangular equations into the other form. So 3 problems today. Going to take one equation that's in rectangular form and convert it into polar form, one that's in polar form and convert it into rectangular form, and then we'll convert this as in polar form. We'll convert that into rectangular form, and we'll sketch the graph. Alright, so looking at the first one, convert 3x plus 5y minus 2 equals 0 into polar form. Now, since I want it in polar form, I want to have r and theta. I do not want x and y in this equation. So I have to think what formulas would be good to get rid of x's and y's, and these are the two that you would want. It's x is equal to r times cosine of theta, and y is equal to r times the sine of theta. Those are the 2 of the 4 formulas that we learned in 10.7 day 1 that we're going to want to use. So simple enough, it's just a substitution. I'm going to say it's 3 times x, which I can change to this, r times cosine of theta, plus 5 times y, which I can change to r sine of theta, minus 2 is equal to 0. And then kind of step 1 of your goals, if you want to think of it that way, is that you've gotten rid of all of the x's and y's, which is what you want to do. Now, if you have both r and theta in your equation, it's like having both x and y. You usually solve for y. Well, for this, you usually solve for r. So now I got to try to think how to get r by itself. Well, I notice that I've got 1, 2, 3 terms. 2 of them have r in it. So what I would want to do is get those 2 terms on one side. So in other words, I need to take this negative 2 and move it to the right. So I've got 3 r cosine of theta plus 5 r sine of theta is equal to 2. So now both terms that have r in it are on the left. Why would I do that? If they both have r in it or have it in common, I can factor it out. And now I've got 3 times, or r times 3 cosine of theta plus 5 times the sine of theta equals 2. I'm trying to solve for r. Don't get confused by the complexity of this. It's r times something, so just divide by whatever this is, and you're going to get r is equal to 2 divided by the quantity 3 cosine of theta plus 5 times the sine of theta. And in terms of solving, you've got r by itself. If these were being multiplied together, you could switch them into cosecant and secant, but they aren't, so basically you leave it like that. So if you understand what to do right away, it's actually not too difficult, it's just understanding what to do. This one, if you kind of look at this, you can see that they're similar, so you're basically working backwards here. Now you have r's and thetas in it, and you don't want those, you want x's and y's, so I am again going to use these 2 conversions. The only way I can change a cosine into an x is if I have an r multiplied by it. So when I look at this, you could say, well, maybe I should multiply by r over r, because that would give me an r down here, and that's one idea. You could do that. Usually what I would suggest is look at the trig functions. Get rid of those first by multiplying them by r. If they're in the denominator, then cross multiply. And that's what I'm going to do here. And it just so happens to conveniently multiply it by r while I do it. So it's r times 2 cosine of theta minus 3 sine of theta is equal to 6. I'm going to go ahead and distribute the r. Now understand this 2 in the cosine, that's all one term, so I only get to multiply one of them by r, and I'm going to multiply the actual cosine by r. Minus 3r sine of theta is equal to 6. And now this is great news and this is great news because I can change those directly into x and y. So this now becomes 2x minus 3y is equal to 6. And then I would take it like this. You could set it equal to 0. You could solve it for y. You could kind of do whatever you want, but typically they usually set it equal to 0. They're inconsistent in how they want their answer, so that's fine. So for this one, not too difficult. A quick little problem to solve. If you look at the one we did in the notes, you see that there are extra steps in there because you've got another r term. But overall, the idea is simple enough. It just depends on what you run into in the problem. Alright, and then the last one. Basically, they could just say graph this right now or convert it into rectangular form so it's something that you're used to seeing and then graph it if that makes it easier. So that's what we're going to do. Now, when I look at this equation, not much of an equation, I do not see r in there at all. So converting it, I need an equation that has x's and y's but no r, and of course that eventually takes you to this equation. Doesn't have r, but it does have x and y. So what do? I'm going to take the tangent of both sides. I'll take the tangent of the left and then take the tangent of the right. Just like adding 2 to both sides. As long as I do it to both sides, I'm balancing the equation. I can now make my substitution. This tangent can change into y over x is equal to, I just need to figure out what the tangent of 3 pi over 4 is. It's over 4, so I know it's a 45 degree, which means I know this tangent is going to be 1 or negative 1. 3 pi over 4, it's a little bit less than 1. It's right here. Negative x, positive y, this is going to give me negative 1. And now a normal equation with x's and y's in it, you solve it for y. So I could say that y is equal to negative x. And these two things are actually the same graph. So graphing this shouldn't be that difficult. You've got a y-intercept of 0, implied to be there. Slope of negative 1, so down 1, 1 to the right. There's your line. Alright, now let's say I was given this, and for some reason you're not allowed to convert, or you're told not to convert, and they want you to graph it. Since this is a polar equation, you're graphing on a polar coordinate axis. All that this is saying is that theta has to be 3 pi over 4. So when you're given this point, think about what you do if I gave you this in a rectangular equation, x equals 1. Well, that means that x equals 1, y could be anything. It could be 1, 0, it could be 1, 1, 1, 2, 1, 3, 1, 4. That's how I end up with that line. Same thing here. All I know is that theta has to be 3 pi over 4. They don't say what r is. That means r could be anything. So, for example, r could be 0. Rotate 3 pi over 4, I'm still going to be on the pole. What if r is 1? Rotate 3 pi over 4, 2, 3 pi over 4, negative 1, 3 pi over 4, and so on, and sure enough, I end up with the exact same line. Not as familiar with working with polar equations, so you probably you look at it now and say, oh yeah, that seems simple, but when you first saw it, you probably didn't think of that, and that's fine, because it's something we're working with for the first time. Alright, if you need extra help on 10.7 day 2, because some of the ones you have in the homework are a little more complicated, feel free to come in the morning and ask for help.